First talk in this session is from SiFive. SiFive is making an announcement actually at the conference here of their open secure platform architecture. And our speaker today from SiFive is Dany Nativel, who is security director at SiFive. He's also the managing director of SiFive France and is responsible for SiFive's platform security, leading a team of hardware and software security experts. In the last 20 years, he's been in the semiconductor industry and roles revolving around security at companies that include Maxim, InnovaCard, Atmel, Infineon, and IBM. Dany.
All right. Good afternoon, everybody. I'm pleased and honored to be here to introduce you to SiFive Open Secure Platform Architecture. In fact, I'm super excited to be here, not only because this is a very special day for SiFive, but also a great moment for the RISC-V community. SiFive has been founded to create silicon based upon the open and free RISC-V instruction set architecture. I've spent the last 20 years dealing with security at a number of semiconductor companies. But I learned a great lesson a few years ago when my daughter came to me. She was 7 at that time, claiming that she was able to log into my laptop account. I looked at her, very amused, and say, you're right, it's just impossible unless you found a way to capture my password. She grabbed my laptop and pressed the escape key from the lock screen, selected another user, pressed the escape key again, pressed enter, and guess what? She was in. And I was shocked because there was actually a bug in the login manager of one of my Linux machines at home that has been patched very few days after that event. So when it comes to security, it just never stops. You need to improve all the day, and you need to check constantly for new attacks. So when you look at securing a modern SoC, there's a couple of things that should be taken into consideration. First of all, legacy is a real burden. A security architecture that has been designed 15 years ago is having a hard time today to catch up with modern multi-core SoC and gigantic software stacks. Trying to patch or maintain such legacy solution add complexity and also add security issues. There's also another thing that needs to be done when you're trying to secure an SoC is to reduce the amount of code that it exposed, to reduce the amount of trusted code that is going to develop for that given platform. That remove bugs and security issues. With the exponential number of connected devices, device ownership becomes mandatory these days because you want to authenticate firmware and you want to allow over-the-air firmware in a secure way. Finally, security through obscurity just doesn't work anymore. People want to have full access to hardware and software so they can properly assess the security of a given system. When we look at the RISC-V architecture, there's a number of things that could be improved to make it more secure. RISC-V comes what we call the PMP, the physical memory protection, which is a great tool to enforce memory isolation at the core level. But it might not scale very well between multiple cores because you need to constantly maintain the same PMP configuration across the different cores. There is also a need for a greater isolation, not only between the cores, but also between the cores and the other bus master sitting on the bus. And on single core products, it would be nice to have a way to isolate processes running in a single core from each other. On RISC-V today, the only way to control the access to a peripheral is to use a PMP region for that, which is a very expensive mechanism. It would be nicer to have a per-peripheral access control to simplify such control. Trying to use a collection of third-party patches to make the RISC-V secure doesn't really come very well with the RISC-V idea of openness. We believe that a unified hardware and software platform should be created to embrace the SiFive open platform architecture. So I'm very pleased today to introduce you SiFive Shield, which is an open secure platform architecture that has been designed for scalability. It aims to provide a system-level protection with a great level of customization. And it has an open specification that we will be promoting and contributing back to the SiFive Foundation. So what does SiFive Shield include? SiFive Shield is built upon a number of layers to provide a complete system-level protection. It starts with a proper root of trust to guarantee device ownership. Then we added a number of hardware mechanisms to prevent and detect threats, as well as the addition of cryptographic engines that have been properly verified to help with stuff like a secure boot, for example. We also provide the right connection to the operating system and the communication stacks to make use of our crypto blocks and other sub-functions. And finally, we are looking at the complete secure lifecycle management, not only from the key management perspective, but also from a system-level perspective where we want to validate and evaluate our blocks and architecture through external security labs. So the root of trust is a very important aspect of any modern device. It starts with the capability to being able to properly store keys and certificates on chip. SiFive is going to offer a service to do key provisioning and certificate provisioning at test, so our customers can really rely on us to inject the proper keys or certificate and can have their firmware that's been signed by them only to be running on this given platform. It really simplifies the manufacturing flow from the customer perspective. We are also open sourcing a secure boot. So we want our customers, we want our partners to look at this secure boot from a security standpoint, from a feature standpoint, so they can modify it, adapt it to their own needs. This secure boot is able to boot from different interfaces, including UART, SPI, Quad SPI, eMMC. It does support version management. It has anti-rollback features. And it also allows our customers to add feature to the secure boot ROM by developing applets that can be signed by our customers. Finally, SiFive is bringing a new secure debug controller on top of the existing RISC-V debug interface to allow parts in the field to be re-enabled back to JTAG mode for proper RMA process. So on the threat prevention aspect, we are doing a couple of things to really raise the bar on the security level on the RISC-V. We start with the existing mechanism found in the RISC-V with the PMP and PMA, which are really great tools to enforce security at the core, execution prevention, and so on. We are adding a number of features and mechanisms to our cache controllers to prevent from some cache attacks that are very popular these days. And on top of that, we are adding a digital sensor that will be disseminating across the chip to detect out-of-range operation of a given SoC. So rather than detecting over voltage, over temperature, or over frequency, we are looking at the consequence of that attack by looking at some critical paths in the chip. And finally, SiFive is going to deploy an hardware-enforced multi-domain security system to provide proper isolation between cores, DMA controllers, bus masters, peripherals, and memories. So for the crypto engines, we are going to offer a number of blocks, starting from a true random number generator that is fully compliant with the latest NIST SP890A, B, and C. This will come with a proper evaluation report. Same thing with the AES crypto engines that supports most, if not all, the different modes of operation, including GCM, CCM, CTR, ECB, CBC, and many others. We also have a number of other blocks like hash engines and public key cryptographic engines. All those blocks here will come with a unified open source cryptographic library that can make use of those crypto blocks. So our customer can use that in their application and also use that to connect to their existing software. On the software and communication side, we are adding new features to our existing ecosystem, which today includes the SiFive Freedom Medal BSP and our SiFive Freedom SDK. So we are also adding wrappers to TLS stacks providers, such as S2N or OpenSSL. And we're also working on developing a number of connectors to provide simplified access to cloud service providers. In parallel to that, we are also open sourcing a multi-domain security monitor that will take care of the configuration, context switching of our multi-domain architecture that I will develop later. So on the lifecycle side, as I said, SiFive is committed to provide a service for key provisioning and key injection. We also want to bring confidence to the community by offering as much evaluation done by third parties as possible. You shouldn't be trusting us directly. You should be trusted people who are working hard on just evaluating products. So we will do that for crypto, TRNG, and also our multi-domain architecture, and many other products that you will see in the summary slide. Finally, we are going through a formal verification of our secure debug interface. So we'll also come up with a report for that. Now that you've seen SiFive Shield, it's my great pleasure to introduce you to SiFive WallGuard, which is a fine-grained hardware-enforced multi-domain architecture that provides data and code protection for core, cache, interconnect, memories, and peripherals. So how does SiFive WallGuard works? Let's go technical. The idea is not to touch the core. We want to remain 100% compatible with the WIS5 ISA, so we don't want to modify that. The idea is to tag all transactions coming from all bus masters with an ID. We call it here world ID that is specific to each bus master. The world ID is propagated through the cache, the different caches, down to the crossbar, down to the memories and peripheral. At the memory and peripheral level, we're enforcing access control and policy management. For example, on the memory side, we added a filter called WallGuard PMP, which is very similar to the PMP found in the WIS5, with the addition of access control list for the world ID. So a given memory region can be dedicated to one world or shared between multiple worlds. Same thing goes for the WallGuard filter for the peripherals. Here, each peripheral, UART, SPY, and other have their own access control list, so you can dedicate one peripheral to a world, or multiple worlds can access the same peripheral. As you can see here, each core here is not aware about being tagged or about being constrained into a given world. This opens up another opportunity for third-party development if the end customer wants someone else to develop code. It could, for example, open up the core N here in the picture to a third party. And this third party can develop code even in machine mode because it would believe it has full access to the system. In reality, this core N can be constrained to work in a given environment with a given memory set and a given peripheral set. The configuration you are seeing here is called core-driven, because the core 0 is called the trusted one because it's the only one that is able to set the world ID of each bus master and also the policies at each slave level. This core 0 could be detrusted later on during the boot process if the policies are not changing, for example. You might want to move that core 0 to its own world, and it could operate in its own world. We have another mode of operation called process-driven mode, which really applies well for single-core products, for example, where we actually map process ID of a task running on an RTOS to a world ID. So each RTOS task works in a given constrained world. We take advantage of the WIS5 capability of being able to run full interrupt support in user mode, to really reduce the amount of trusted code running in machine mode. So in that case, we will have only the security monitor doing context switching and process ID setup running in that very specific environment. The rest will be entirely running in the user mode. The rest of the operation in that mode is very similar to the previous slide, as everything is filtered at the destination. Now that you've learned about SiFive Shield and SiFive WallGuard, let's walk through the competitive advantage of SiFive Shield versus some of the competitive solutions that you may have heard about. First of all, the number of walls is not limited by architecture, it's limited by our customer decision. They decide how many walls they want, depending on their use case and application. The closest competitive solution is limited to 2 walls, a trusted one and an untrusted one, which really limits the configuration, and also doesn't make that very compliant with multi-core environments, where SiFive Shield has been designed for that from day one. Due to the simplicity of the tagging process and the way it doesn't interfere with the core, the software complexity remains very low with our solution compared to competitive solutions that have been patching security over time and added a lot of complexity. We are not touching the ISA, so no recompilation is needed. There's no new instructions like others have been added over years to control their trusted and untrusted world. We do support interrupt in user mode, which really simplifies a lot of things when it comes to security. And on the key provisioning, we believe that having a single point of contact for your entire root of trust makes things much easier for a customer to assess the overall security level. Finally, we are open sourcing our secure boot. The competitive solution has done that recently, but only on the latest version of their core, so they haven't open sourced anything for the previous generation. So here's a summary of SiFive Shield offering. As you can see here, there are about 14 external evaluations that we will be running on the IPs, software, and architecture. There are also up to 8 community evaluations that we will be running as well, because there are some IPs and blogs that really requires community and universities to work on and dig into assess the security level. SiFive is committed to the RISC-V community, and as I said before, SiFive will be contributing and promoting that SiFive Shield and SiFive WallGuard architecture to the RISC-V Foundation, hoping to get wider adoption by the other members. So again, keep in mind that SiFive Shield is an easy-to-adopt, scalable, and that addresses system-level security for your next-generation RISC-V IC. We are working hard at SiFive to constantly improve our offering. On our core IP products, for example, we are doing a quarterly release with new features, new updates, and so on. We are doing the same for security. So we will add new features on our security IPs. And by the end of the year, we'll be introducing the crypto blocks, the secure boots, the key provisioning. Early next year, WallGuard will show up. And we're also looking at 25 gigabit per second AES engine, DDR encryption and integrity, as well as for the future control flow integrity and post-quantum cryptography once everything is standardized. So SiFive is really the leading company for RISC-V IP for premium market that requires a scalable and system-level security that SiFive Shield can offer, and that can be applied to cloud and data center, automotive, mobile, and IoT. So thank you very much for attending this session. You can follow us on Facebook, Twitter, LinkedIn, or SiFive.com for our next great announcement. Thanks a lot.